Hello, I'm Doyeon Kim from Security R&D team. In this session, I will introduce my research about new smart contract fuzzing technique, which is the advanced version of my master thesis. Today's presenter is me, but I emphasize that not only me, but also other researchers participated in this research. And this research paper has been accepted in the Automated Software Engineering 2021, which is one of the top-tier conferences on software engineering. The session title is Smartian, Enhancing Smart Contract Fuzzing with Data Flow Analyses. I know there are lots of unfamiliar words, but don't worry. Today's my goal is not to make this 40-minute session boring by showing how difficult it is. I want you to understand the research by my easy explanation and therefore you get interested in it. I will explain meaning of the old terms in the title. Please keep focusing on me. Before the presentation, let me introduce myself. I am a software security researcher at Security R&D team in Line Plus Corporation. I joined here in January of this year, and I'm currently interested in software security, software engineering, and machine learning. I hope to present other researches on different fields for the next Dev Day. This is the agenda for the session. First of all, I will explain why secure smart contract is really important on the introduction section. To protect smart contract, we implemented our ideas on a practical open source bug finder named Smartian. So I will explain about Smartian on the Smartian section. Our experimental results show that Smartian is more effective than existing state-of-the-art tools in finding vulnerabilities from smart contracts. So I will show the concrete experiment results on evaluation section. And finally, I will end off this session with conclusion. After my presentation, if you have interest on this research, you can read our paper or explore all source code because it is totally public. So, let me start my presentation with introduction. Line develops various blockchain business. I think all of you have heard one of the business at least once. To keep those services safe, we are trying our best to protect smart contracts, which is the basic component of dApps. dApp is decentralized application which is running on blockchain. Then, what is the smart contract? I think all people already knew about it. So, with short explanation, smart contracts are just like contracts in the real world. The only difference is they are completely digital. And it is a tiny computer program stored inside a blockchain. Then, how does the smart contract work? So, have you heard about crowdfunding? Crowdfunding is funding an idea or a project by raising small amounts of money from a large number of people. There are usually three types of actors in crowdfunding. First is a creator. A creator is an initiator who proposes an idea or a project to be funded. Creator can be multiple people. Next is investors. Investor wants to support the project. They usually give money to a creator for support. Last is crowdfunding platform, which is a moderating organization between creators and investors. So, let's look at the crowdfunding example. Assume that there are three types of actors. First is creators, who want at least $10,000 to make a novel product, but they have no money. Next is crowdfunding platform. It will mediate between the investors and the creators. Last is investors who can help creators. So, these creators are same with previous slides creators. Creators need at least $10,000 to make a product, but they don't have enough money to make the product. Creators need to get investment from someone, so they need to find investors who can support them. One solution is creators can go to the crowdfunding platform. In the crowdfunding platform, there are a lot of people who want to become investors. If creators can succeed to get investors' attention, then they can get a lot of money from investors. So, creators introduce their products to crowds who will become investors for creators. Some investors feel interesting to creators' product and decide to invest to them. And investors transfer their funds through the crowdfunding platform. So, the crowdfunding platform waits until getting at least $10,000. If the investors invest at least $10,000, the crowdfunding platform transfers all the money to creators. But if their product fails to get attention to the investors and fails to get investment, then the crowdfunding platform retransfers funds to each investor. So, remind the smart contract. Smart contract is a computer program implemented by developers, and it is stored inside a blockchain. So, a smart contract can be totally replaced with previous crowdfunding platform. On crowdfunding example, because it is a computer program. That means if creators want to get investment, they don't need to go to the crowdfunding platform. They don't need third-party system. They just deploy their smart contract, which can operate same with crowdfunding platform, and wait until they can get enough money. But it is possible to exist a bug in a smart contract because the smart contract is implemented by developers who can make a mistake during development. So, if there is a problem in the smart contract, what will happen? For example, it is logically correct to transfer money to the creators if the funds are at least $10,000. But assume that there is a problem in the smart contract. The problem is anyone can easily change creator's account. So, an arbitrary user can change creator's account, and it can transfer all the money to the arbitrary user's account, not real creator's one. In the real world, there are a lot of happening which an attacker uses such a smart contracts problem. So bugs in smart contracts can cause catastrophic failures because smart contracts often handle digital assets worth millions of dollars. To prevent such a disaster, finding vulnerabilities in smart contracts before deployment on a blockchain is really important. So, there has been surging research interest in automatically finding bugs in smart contracts. These are examples of bug-finding tools for smart contracts. And there are three types of bug finders: verifiers, symbolic executors, and fuzzers. Among them, these tools with green highlighter are all fuzzers. Then, what is a fuzzer? Before I explain about fuzzer, you need to know about fuzz. Fuzz is generating a stream of random characters to be consumed by a target program. And fuzzing is the execution of the program under test using input samples from an input space that protrudes the expected input space of the program under test. That means fuzzing is a process of repeatedly running a program with generated inputs that may be malformed. So, fuzzer is a program that performs fuzz testing on a target program, and fuzz testing is the use of fuzzing to test if a program under test violates a security policy. And it sometimes uses feedback from program under test to do effective fuzzing. Due to its effectiveness, many industries implement their fuzzers. So, we can categorize fuzzers into 3 groups: black box fuzzer, white box fuzzer, and gray box fuzzer. Black box fuzzer cannot see the internal of the target program. It only observes the input or output behavior of the program. White box fuzzer is opposite of black box fuzzer. It can observe whole internal of the target program. It can generate test cases by analyzing the program and the information gathered when executing the program. So, overhead is typically much higher than black box fuzzer because its implementation often employs dynamic instrumentation and SMT solving. Gray box fuzzer is a middle between black box fuzzer and white box fuzzer. It can gather some information in the internal of the program. Unlike white box fuzzer, it does not perform with heavyweight overhead. It may perform lightweight analysis on the program or gather dynamic information about its execution like code coverage. It just relies on imperfect information in order to gain speed and be able to test more inputs. Back to the bug finding tools for smart contract. Most of the fuzzers to find vulnerabilities in smart contracts has many problems. For example, some tools don't report where the bug is triggered. Also, they cannot store test cases, which increase code coverage. This makes it hard to quantitatively compare which tool is better or not. Or, some tools are not open sourced. Also, data used in their experiments are not open sourced. Or, some tools don't detect various bugs in the real-world smart contract. This problem makes each tool limit their usability. Additionally, there is one more critical technical challenge for fuzzers to find bugs in smart contracts. Basically, a traditional fuzzer for binary program usually uses code coverage as its feedback. However, it is not enough for smart contracts because a smart contract has its own feature that is persistent state. The main challenge is handling stateful transaction. A smart contract takes in a sequence of transactions as input while maintaining a persistent state. So, we need to find the transaction sequence that can change the persistent state in a critical way. Current fuzzers for smart contract handle it either by randomly varying transaction orders or by resorting to machine learning. However, all of them is not deterministic. Therefore, all fails in detecting crucial transaction sequences. Let's see an example. You remember previous crowdfunding example. There are 3 types of actors: creators, investors, and crowdfunding platform. Among them, crowdfunding platform is replaced with the smart contract, which is this code. So, please look at the pseudocode in details. If crowdfunding is opened by a creator, it is possible to invest because invest function only can perform after crowdfunding is open. And if the fund variable, which is a state, is more than $10,000, transfer all the money to the creators and the crowdfunding is closed. But assume that there is a bug in the send all funds to creator function. This send all funds to creator function is real code written in Solidity. Message sender with green highlighter is a person who invokes a transaction. That means message sender is a person who calls the send all funds to creator function. And transfer function, which is a built-in function, can transfer money, which is fund variable at this code, to the message sender. Then, can you guess how to trigger a bug? Hint is in subtitle. Bug example for broken access control. I hope all of you knew about it. The bug is to be able to transfer all the money to the attacker, not creators, because closed crowdfunding can be called by anyone. Therefore, message sender in send all funds to creator function can be anyone. You remember that the bug is only triggered when amount of funds is more than $10,000. Then, how to patch? One solution is you can insert a code checking who invokes the transaction before transfer money to a person who calls the transaction. Required statement is if given condition is false, revert all things during the execution of the transaction. So, only creator can execute transfer function and finally make open variable as false. So, before the patch, to trigger the bug, transaction order, which is same with order calling functions, must be open crowdfunding function and invest function and then close crowdfunding function. And sender of open crowdfunding function must be creator because if funds are more than $10,000, invest function must be executed at least one time. Invest function is only possible to execute when crowdfunding is open. To open the crowdfunding, sender of open crowdfunding must be creator. It looks trivial, but most of the bug finding tools, including fuzzers for finding bugs in smart contracts, do not care about transaction ordering and sender. So, they are hard to find such a bug. Actually, it is really hard to automatically generate such a transaction sequence because 3 elements must be satisfied at the same time. First is transaction order. So, shortest transaction sequence is open crowdfunding function, invest function, and then close crowdfunding function. But it's okay to call invest function several times. Second is transaction arguments. So, if the sequence is like open crowdfunding function and invest function and then close crowdfunding function, value of invest function must be at least $10,000 because funds variable must be at least $10,000. Last is sender of transaction. To open the crowdfunding, call the open crowdfunding function with creator sender. Therefore, our team implemented Smartian, which is a fuzzer for finding bugs in Ethereum smart contract. It can find proper transaction order, transaction arguments, and sender of transaction. Also, it easily reports where the bug is triggered, and it is open sourced, and it can detect various bugs in the real-world smart contract. I hope you are interested in how to find such bugs using Smartian. So, let me start to explain how to work. So, what is Smartian? Smartian is a gray box fuzzer for smart contracts supporting that reports where the bug is triggered, and it is open sourced, and it can find various bugs in the smart contracts. And it is able to systemically generate critical transaction sequences with static and dynamic data flow analysis. This is the whole architecture of Smartian. There are mainly 3 steps: information gathering, test case pool initialization, and fuzzing. Note that test case is same with transaction sequence or seed. Anyway, I will explain each step. If the smart contract source code is compiled, then it becomes an EVM bytecode. EVM stands for Ethereum Virtual Machine. It is an environment to execute the smart contract, but you don't care about that. Smartian gets EVM bytecode as input and gathers information using static analysis. Static analysis is an analysis before the execution of smart contract. Smartian gathers information about smart contract state variable, data flow facts, or who invokes a transaction. This gathered information transfers to the test case pool initialization step as input. Using the information, Smartian makes test case pool, and we hope such kind of test cases to find bugs, but it is before the execution of the smart contract. So, we don't know these test cases can really find bugs, so we need to execute using such test cases. And fuzzing step takes this initialized test case as input. So, this step is fuzzing, which Smartian executes a test case same with transaction sequence. Smartian randomly generates a test case with concrete value using prior test case pool. And during the execution of target program, Smartian does dynamic analysis. Dynamic analysis means an analysis during the execution of the target program. So, Smartian gathers information which state is defined in a transaction or which state is used in a transaction. If it finds some new code coverage or new depth use chain or find bugs, then this test case is marked and reused as test case. So, let's summarize them. First is information gathering. It runs a static analysis to collect useful data flow facts, and it gathers which state variables are defined and used by the function, and facts related with center. Next is test case pool initialization. It predicts which transaction sequences are meaningful based on the gathered information, and consider them as initial test cases. And it sets the arguments of each function as default value. Last is fuzzing step. It finds concrete values that can penetrate branches with gray box testing. It gets feedback if there is a new data flow facts during a dynamic analysis, and it can detect various bugs with help of our own bug oracles. So, it's quite difficult, so let's remind the crowdfunding example. In the information gathering step, Smartian knows there are 3 state variables named open, funds, and creator. And there are 3 functions: open crowdfunding, invest, and closed crowdfunding. And in the open crowdfunding function, open is defined and open is used in the invest function. Also, in the invest function, funds is defined and funds is used in the closed crowdfunding function. Also, in the information gathering step, Smartian knows that if open becomes true, sender of open crowdfunding function must be a creator. During the information gathering step, we gathered 5 facts. Open variable is defined in open crowdfunding function. Open variable is used in invest function. Funds variable is defined in invest function. Funds variable is used in closed crowdfunding function. And to define open variable, sender of open crowdfunding function must be creator. Smartian sends these facts to test case pool initialization step. In the test case pool initialization step, Smartian looks open crowdfunding function, and it knows there is the definition of open, and it next finds where open is used. Thanks to the information gathering step, it can easily know that open variable is used in invest function. And it finds which state variable is defined in invest function. So it can know that funds variable is defined in invest function. Next, Smartian also finds where funds variable is used. Also, it can easily know that funds variable is used in the closed crowdfunding function. So, with this information, Smartian constructs a test case like this because there are new to define use chains and it sets the arguments by default. Using the test case, Smartian does fuzz testing to the target smart contract. But thanks to the previous information gathering step, we know that when the standard of open crowdfunding is not a creator, open state variable never be true. That means anyone cannot invest. So Smartian can set the standard of open crowdfunding as creator. When the execution of this transaction sequence, we cannot find this bug because it cannot penetrate the branch in the closed crowdfunding function because funds variable is 0. So the argument of invest function must not be 0. So we failed to discover the bug, but during the execution of this transaction sequence, Smartian can find new to define use chains using dynamic analysis. So this test case considered as good test case to find bugs with high probability. So this test case gets the chance to re-execute. So during the execution, Smartian knew that there are new defined use chains in the transaction sequence. So it marks the sequence as meaningful and will retest the sequence. Also, Smartian knew that if it passed the branch, the argument in the invest function should be at least $10,000. In the refuzzing step with dynamic analysis, Smartian sets the argument of invest function as $10,000. And it executes this transaction sequence. And finally, Smartian finds a bug in the closed crowdfunding function. So, are we on the same page, right? Yeah, we know that Smartian is gray box testing tool with data flow analysis, but is performance better than other tools? To answer the question, I share you about the evaluation. This is our environment for evaluation. This information also can be found in our paper, so I'll skip this slide briefly. In comparison targets, we selected 2 fuzzers and 2 symbolic executors. To select fuzzers, we filtered open source fuzzers that are published in top conferences and have good performance, and we obtained ILF and SFuzz. To select symbolic executors, we initially applied the same criteria, but there are a lot of problems in existing tools, so it is really hard to compare. Therefore, we chose Ethereum and Manticore, as they support various bug classes. This table is a summary of our benchmark we used. B1 is from VerySmart, which is a static analyzer for integer bugs. It is a realistic benchmark with non-vulnerabilities, and it all assigned CVEs. B2 contains more bug classes by extracting contracts from SmartBug, but there are a lot of toy contracts. B3 contains 500 popular and complex smart contracts obtained from Etherscan, which is an online platform that provides code and statistics of Ethereum smart contracts. We first downloaded contracts that have more than 30,000 transactions and filtered out contracts that do not compile with the Solidity compiler version we used. Finally, we sorted the remaining contracts based on their bytecode size and selected the 500 target contracts in order to gather both popular and complex contracts. This is the first of our evaluation. We wanted to know that our analysis helps Smartian find bugs more effectively, and also we wanted to know its overhead. We used B1 here because each contract in the benchmark contains a previously known bug, which serves as ground truth for our evaluation. Also, all the contracts in B1 are real-world contracts, whereas some of the contracts in B2 are toy programs. So, our results show that with both an static and dynamic analysis is best results, although it increased only 1% more instruction coverage. Also, we evaluated how much overhead is imposed by applying our analysis, so we confirmed that there is only 2.7% overhead. Next is bug found comparison against state-of-the-art tools on subset of B1. Some tools didn't work on several smart contracts of B1, so we compared with subset of B1 that all tools can work. We excluded ILF because it doesn't support integer bug oracle. So, Smartian found most CVE compared with other tools. Next is code coverage against state-of-the-art tools on subset of B1. So, Smartian covered most instructions compared with other tools. Next is bug found comparison against state-of-the-art tools on B2. Smartian found most bugs compared with other tools, and the surprise thing is all bugs found by Smartian are true positive. On the other hand, other tools alarmed many false positives. Next is code coverage comparison against state-of-the-art tools on B2. Smartian covered most instructions compared with other tools. Next is about the number of bugs found by Smartian on B3, which is dataset of popular and complex 500 smart contracts. This is table of reported bugs found by Smartian. And we confirmed that which one is true positive or which one is false positive. So, Smartian found 219 bugs reported in real-world smart contracts, including 211 true positives and 8 false positives. Most integer bug patterns of bugs are similar with B1. That means many developers do copy and paste vulnerable code. And 8 false positives are due to the imperfect of bug oracles. So, this is the end of the session. We learned that secure smart contract is really important, right? So, To protect the smart contract, we implemented Smartian, an effective gray box fuzzer with static and dynamic data flow analysis for finding bugs in smart contracts. Smartian shows best results compared with other state-of-the-art tools. Please read the paper if you are interested in the research or you want to learn in detail. Smartian is open-sourced, benchmark for evaluation, and scripts that we used when evaluation are also open-sourced. If you have interests, feel free to explore the code. Also, I always welcome your star. For your information, this research was started when I was in master degree, so all the codes have been published from my previous lab. And thank you for your attention, although this presentation is really long. Don't hesitate to ask me about this research, or if you want to ask me later, feel free to email me.